Hello everyone, this is Revati, working as an assistant professor in the Department of Information Technology. In my today case study, we are going to see about distance vector routing algorithm. Today our problem statement is to develop a distance vector routing algorithm which each node present in the network is going to exchange its routing information with its all other nodes in the network. It also ensures the effective and adaptive exchange of data with its dynamic network environments. Now, our students will going to explain this problem statement using an example problem. Thank you. Our students' team members are Nasri, Indu, Vanasri, Abhi, and Manjusri.
Let's see about routing. Routing is the process of selecting the best path for data to travel from one device to another device with the network or between a network. To determine the best path by using protocols and routing table. Routing has two types, static and dynamic. Static is predefined and dynamic is automatically change the best path. Applications of routing: sending emails, streaming videos, phone system and web browsing. A routing protocol has two types, unicast and multicast. So unicast, a method which sends the data from single source to single destination. Multicast, a method of a data which sends the data to single source to multiple destination or a multiple destination to single source. First we should calculate the initial state for each path. First we take two columns A, B. The final routing table for B is B2A is 5, B2B is 0, B2C is 4, B2D is 8 and B2E is 3. We have to find the final routing table for each and every node in the network. At node A, first we have to identify the neighboring nodes of A. Here the neighboring nodes of A is B, C and D. So from A to B, we have to find the all possible paths. So A to B paths are, A to B is a direct path with 5. Next one is B to B. So distance between A to B is 5 and B to D is 0. So the value is 5. Next possible path is A to C and C to B. The distance between A to C is 2 and C to B is 4. So the value is 6. The next possible path is A to C. A to C value is 2 and C to E is 4 and E to B is 3. So we have to calculate the minimum values within the values. So the minimum is 5. So from A to C, we have to find the all possible paths. The first path is A to C and C to C. The distance between A to C is 2 and C to C is a self node, so 0. So the final value is 2. So next is A to B. So A to B value is 5 and B to C value is 4. So the value is 9. The next possible path is A to B. So A to B value is 5 and B to E value is 3 and E to C value is 4. So it is 12. So in this the minimum value is 2. So like that next way is A to D. From A to D, A to D path is 3 and D to D is a self node, so 0. So the value is 3. The next possible path is A to B, B to E. A to B distance is 5 and B to E distance is 3. So the value is 8. The next possible path is A to C. A to C distance is 2 and C to D distance is 4. So the value is 8. In this we have to calculate the minimum value. So the minimum value is 3. So the final routing table for A is
way to determine the simple part. So before small and medium network. Hello everyone, I hope this video will give the clear idea about the distance vector routing, and also it will gives the clear conclusion about the shortest path in the networks. Thank you for watching.